That and you have to put something else on there. I said that's not how I'm going to do it. Hi again. So I basically want to go ahead and start working on another introductory video of the percentages with fraction models. So I'm not going to spend that much time doing it. I'm just going to just work on. I'm not going to spend that much time talking. I'm going to work on it, and I'm just going to hear me speaking about the problems. So here it is. You have the circle below represents one value, and you have 1, 2, 3, 4. Is what percent is represented by the shaded area. And then you have, so, we could look at this whole circle here. We could say this whole circle right now is one whole, Then if you cut it in half, you kind of shade it in this piece, that would be 1/2. And I'm using English. If I can use Japanese, 日本語でわかりますか? 中文可以吗? If anybody wants anything, let me know. If you understand, if you want me to maybe write it in some other language, it's fine too. So anyway, so we have the 1/2 here, and then we have this over here. So we have this, and we have this. So these are actually this is not 1/2. This is actually 1/4. They're basically put in 4. So if we shaded this whole thing, we can say 4 over 4, because it's 4 pieces, which is also equals 1 whole, And just fun fact, if you see things like this, they're actually all equal to 1. So now here, this now we can go back here. We can see that we have this 1, 2, 3, 4. So that's basically 2/4. So it's half. So we could say 50%. Next one here, it looks like we have 1, 2, 3, 4, and then you have 1, 2, 3. So we have one side has 3/4, and this side has 4/4, like as I said before. So we can look at this, we could say 4/4 plus 3/4, which would equal 7/4. So there's a way that I would normally do this. What I would do is first we would go ahead, we would just say here's 100, right? And then here you have I like to look at the in the American US dollar, which is you have like 25 cents. It's kind of like saying 25%. So I used to say 4 quarters make $1. More quarters make $1. So 4 quarters make $1, and then that's 75% over 100. Or you can say we're gonna try to bring this down to 70. We could do that. That makes sense. So then we can say 75 over 100. 75 over 100 plus 75 over 100, which is basically 175 over 100. So 175%. Okay. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 14 that are not shaded. And then you have inside, you have 6. 1, 2, 3, 4, 5, 6. So 14 not shaded plus the 6 are shaded equals 20 pieces that are shaded. That's 20 pieces in total. We want to show this large rectangle represents only 6 of them. So that means we have 6 over 20. So this is how many spaces there are in total. These are how many pieces are shaded. And what we want to do is we want to say what percent is represented in the shaded area. Well, this one is a little bit more outside of the easier scope of what we usually do. So what we could do, we could just start with, 6/20, start dividing it. How many 6 can go into 20? So we have, 6 plus 6 is 12, right? And then we know if we add another 6 is 18. And that's pretty as much as far as we're going to get, because the next, if we add 6 more, we're going to get 24. And that's too big. So we're not going to use that. So we're going to say 18. So what we're going to say is 6 goes into 20 3 times. And we put 3 here. And we say 3 times 6 is 18. Now we have this 20 here. Remember from the very first video when how you're dividing it, we're going to put a dot here, because what we're going to do, now we're saying that now this is a fraction. It's smaller than 1. And then we put a 20 down here and we say, oh, how many times does 6 go into 20? And then you say 6 goes into 20 3 times again, and you probably could start seeing what's going on right now, right? So you can see we're probably going to get a repeating 3, right? So let's go ahead and look at how we can represent this in a fraction model, or how we can represent this in a percentage. So we would basically continue, probably can do like 33, right? So it's going to continue to do that over and over and over again, So we get a repeating decimal. So what would this do? So 3.33 is pretty much where we're going to stop. We can't say 3. We can't just say it'll be. We see. This is. If we say, if we have 10% here and we want to go from, if we want to say 10 like this, we would basically we move it 2 points to the left to get that. Here, you can say 1, 2 like that to get a percentage. So we could, can we say 33%? That's like 3 times the amount. So I don't think that's what it would be. So let's see if we can eyeball it and see what happens. We know that we have 6 here. We know that if this was an even number, let's say if it was actually 24, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? There's 20 of them. So, and there's 6 shaded in there. How would that look? All right, let's go ahead and look at the idea if it wasn't 20. Let's say it was just 5. Now 5 would be a little bit easier to kind of have a better understanding of what was going on, because 5 goes into 20 4 times, right? We know it goes, so because of course 5 times 4 equals 20. So that would mean that this would kind of be 1/4 the size, right? But that, and also that would also mean that it would be 25%, because that would mean that we would have, that's how much we would have if we were having 5/20, 5 over 20, which is equal to, which is pretty much 1/4, which is also 25%. But if you have 6/20, there's more shaded region. So that means that we have something a little bit bigger than 25%, right? If this was actually 10, right, we would know it would be 50%. So we know it's between 25 and 50%. That's a good assumption to make sure we know. We know it's between 25 and 50%. Okay. So between 25 and 50%. So 6/20 has to be somewhere around that'd be somewhere beyond that. Let me check this out real quick. If we had 20 here, if 5 goes into 24 4 times, right? And then we would have 4. And then 4 to 4 is 20, and that's 4. And then what we would do is how would we do this? Yeah, we have 4 here, and then we want to convert the 4 into a percentage. We would start here, and we go. Oh wait, no. Yeah, it's actually it's decimal. Yeah, it's a decimal there because I think that I'm actually doing the actual problem differently. I think because if I did this, then we would do it. How many times is 20 go 5 0, and then we would say 0 times 0, 0 times 20 is 0, right? And we bring a 0 down, and then we say how many times is say how many times 50, right? And then we say 20 goes into 50 2 times, right? And we say 2 times 20 is 40, and we bring down this 110. And then we say how many times does 20 goes into 10? And we say 0, and bring the 0 down. We say 20 goes 5, 5, and that's how you would do it. And that's how this is how we would get. This is how we would get the 25%. So this is actually wrong. And you see how I was using the wrong technique, but I still understood the answer. That's why I do this, because this is not really, this is kind of like they want you to intuitively get to this. You know, I don't know. I think that they wanted to get you to intuitively get to it because then it would help you to, solve the problem better. But I feel like I only would get to this. I would only look at this if I watch other people do it. So now that I know that, now we can go back to the original problem, where it's when you're trying to find a percentage, it's not 6 go into 20. It's actually 20 goes into 6. Now this actually helps me to understand like what the difference between those things are. When you have 6 goes into 20, we're trying to figure out how many times the 6 goes into that. We're going to get usually a decimal, a close decimal point. But if you do it this way, we're actually getting a higher decimal. So we're going to get a decimal right off the bat. So we know 20 goes into 6. How much 20 goes into 6? 0 times. So we say that automatically. Oh, it's 0. And we say 0 times 20 is 0, right? And then we go ahead, we put a decimal here, we bring a 0 down here. And then we say 6 goes into 0, and we say 60 like that. And now we say how many times does 20 goes into 60? And then we say 3 times. And then you say 3 times 20 is 60. Now we have an answer, 30%. And we can go ahead and try that and see if that works. Now, remember, once we get 0.3, we in order for us to get to 30%, we have to go ahead and move the decimal point 2 places, 1, 2, right here. And then a 0 gets put here. And then once you put the 0 there, then we put the percentages here. That's why it looks like this. This is my theory. Yeah, okay, so that works. So that now it helps me to understand like how to solve that, because in my mind, I know what I'm supposed to get, but the steps to get there takes too long and it's very hard to go through with it. And usually I'm trying to solve things very fast because of the fact that, sorry, my nose is running. Okay, so that's basically it right there. So we have squares below, it only says one whole, right? So we have here square below represents one whole. So we have here 1, 2, 3, 4. Now remember, they don't have the small little blocks in between, right? Because we're just representing each slab equals to 1/10, right? So we have 1, 2, 3, 4. So that's basically 4/10. So 4/10 is actually shaded. If you remember now, we can go ahead and we can do our division, right? 0.0 is 0. And then we bring the 0 down here. And then we say that goes into 4. 4 times 2 is 40. We know it's 0. So that's my new weapon. That's my new weapon. Okay. So then you have that. So then you have 40%. Now we move on to the next one. Right. So 4 is corrected 333 points. And that's it. So I can see I gotten pretty far with that. That was actually pretty good. So this part, obviously, I actually took the test before I started. This is pretty good. Probably let's do another one. All right. We have here expresses the shaded area. Express the shaded area as a fraction, a decimal, and a percent of a whole. So we could say here. Let's go ahead and let's zoom in a little bit. And let's look at our numbers. Okay. All right. So we have here 1, 2, 3, 4, 5, right? So we have 5/10, which is equal to 50%. We don't even have to do division, but if you wanna know the division, it's always gonna be like this. Remember, and we get this at the top because of this. See how I can save that in my head now. So now what we have is you have 0.5. So now we can look at this fraction and we can say like that. And for the decimal part, it's like this. Just like we have this piece up here, right? And the percentage is like this. Now, I know somebody will probably have an answer about why we won't say 5%, right? Well, remember that 5% wouldn't be, because if we want to go from this to this, that transition requires the decimal place to be moved to here. And then when the decimal place is moved over there, then we put, instead of us just showing the decimal, we actually show the entire percent. And then that's where we get that. So you can just go ahead and put that there. All right, here we go. So let's move on to the next one. I'm not gonna say anything in this one. I'm just gonna go ahead and just I'm just gonna do the math, and then you could just watch me. So now we know what we're going to get. We're going to get 38 per 100. We're going to get decimal point is going to be 38%. And then we have percentage is 38%. There you go. Now, this one we could just eyeball because we only have two here, right? Two unshaded regions. Actually, I did this wrong. I want to actually do the opposite. This is basically the how many blocks there are how many blocks exist, and these are how many blocks unshaded. So if you want to know how this formula works, this is probably a little bit advanced. Existing blocks minus unshaded blocks. That's kind of like what my function is. So, and then when we do that, we're gonna get 98. So now you remember, it's gonna be 98 over 100. Remember, we do this, which is gonna give us this. And then we're gonna move these things over here to get 98%. So the fraction is this. This is the decimal, and this is the percent. Now you want to do this yourself and think through it, because it helps you to actually get through with it. But if you get stuck on something, this is a great way to like look at how to get it done. Right. We're just gonna we already know we should know how big this is right now. We're gonna just say 1/2, right? And the percentage is 10. No. I don't know why my like not right there. All right, there you go. So you could see that this is a percentage, and decimal fractions and percentages aren't really that bad. It's very straightforward. The only thing I think that can make it very difficult is that sometimes knowing where the decimal place is, knowing how to divide, how to decide those things it takes a while. It takes a while to actually solve those things. But if you've already done it pretty well and you're really good at it, the problem about it is that you probably won't even see the problem. And that's what I really feel like when you have students, you should find out which student is really good at the problems, at solving those. And then you need to find the students that are struggling with certain problems and then mix them together to give an opportunity for the students who do see the problem and the people who don't see the problem. And then they can explain to each other what they don't see and what they do see. And this will help them to solve the issues in a way that is more beneficial for both of them. So one, for example, you might run into an issue where this will become so easy for you that you'll forget that everybody is not as fast as you are. So, and then you might have an issue where you might run into an issue and you might move in so fast that you leave other people behind. And it's not really great to leave too many people behind, because you do need to have a certain amount of people ahead of you, or at least around you, so you could measure on how far you're actually going. For example, if you are a meteor outside in outer space, knowing how far you've actually have gone can only be measured by how fast you're actually going. And going somewhere is only possible if you know where you've been. But like if you're this meteor in like a vast amount of space and there's nothing around, just pure darkness, and you're just moving, speed and time doesn't really matter. Like you need to have definitions of where you are in your understanding. And then when you actually write your problem or your expression or your mathematics issue, then you will notice that, oh, this is what I'm trying to explain, So, this is what I basically look at. I even try to write my papers mathematically, where I structure like a decent amount of information at the top, like what up a definition. Then I kind of like write down different paragraphs, and the paragraphs are like functions and like encoding, where you're trying to take an argument. Usually it's an argument. It's like right now, I think that math should be taught in a more collaborative way. And then I would say I would take your argument showing that how collaboration is utilized in normal society. Then I focus on how I think classes are formulated outside of society, and then I start to bring different points, returning different ideas and stuff like that until there's a conclusion of what these things are. It's a level of formal argumentation. It's so weird because we tend to act like we don't have the same mindset when it comes down to understanding things. But honestly, what happens is that if you're not able to get people's ideas across, it's not just your fault. It's also the other person's fault, because either that person's not listening, or you're not able to target your audience with what you're trying to say. So you'll realize how I'm going through this, because I plan to do a whole bunch of different examples, not just with math, even with programming, to try to help people understand on what they need to do. So anyway, that's it. Thanks a lot. See you guys in the next video.